Very good morning, good afternoon, good evening, my dear friends. Welcome to this data analysis and decision making 1 course under the NPTEL MOOC series. And as you know, this is a 12-week course, total number of hours is 30. Each week we have 5 classes and each class being of for half an hour. And I am Raghunandan Sengupta from the IME department, IIT Kanpur. And obviously, this is the 18th lecture, that means we are in the 4th week, and just to clear up in your memory that this is DADM 1. So, obviously, there would be DADM 2 which will cover maximum part being operational research, this DADM 1 being more from statistics and multivariate statistics, and DADM 3 will be more from computations perspective for both DADM 1 and DADM 2, machine learning, artificial neural network and all the processes where we use a lot of computing powers to do analysis for data, analysis for decisions and all these things. Anyway, coming back to this course of DADM 1, this is the 18th lecture. So, if you remember, we are discussing about, we started the 16th and the 17th we dealt with method of moments, then we dealt with maximum likelihood estimation concept, and then how the point distribution for different type of parameters for a distribution could be found out. This is just I am recapping, so please have some patience. And what we wanted to know is that given a population distribution, if the parameters were known, our life was fine. No worries about that, we could use those parametric distribution to solve our problems. Now, if the parameters for the distributions are per se not known, so obviously those parameters have to be found out. And in order to find out those parameters, we have to use some methods. So, in the method of moments, what we did, which is the second method which I discussed, what we did is that we found out the moments, the first moment, second moment, third moment, first moment being related to the mean, second moment with along with the first moment would give you some information the variance. Similarly, the third moment, second moment, first moment would give you some information of the skewness and so on and so forth. So, we found out the relationship of the moments in the parametric form. Consider the parameters are not known obviously for the distribution function PDF for the population. We found out some equation relationship. Then what we did, we took up a sample of size 1 to n, utilize the moments of the sample with respect to the information which is given in the sample, found out the parameters using the sample statistic or the sample information or the sample characteristics. Once they were found out, obviously you have to solve the different sets of equations. They may be closed form solution, not closed form solutions, that is a different question. We can use iterative methods and other things to find out the estimates, and those estimates were basically the best estimates with respect to the parameters which you want to find out. So, if there is only one moment, one parameter, you will use the first moment. If there are 2 parameters, you will use the 2 moments, first and second, and so on and so forth. So, for the problem which was shown in the or the slides which were shown, we considered there were k number of parameters, hence we took the k moments, and considering that we found out the estimates from the sample for these k parameters and proceeded. But obviously, when we proceeded, we double checked that the estimate of the parameters which were found, whether they adhere to the property of unbiasedness and consistency. And if you remember, I have given the concept of unbiasedness and consistency using a diagram, where average values being the same with respect to the population expected value was unbiasedness, and consistency technically would mean that as the sample size increases, the variance basically would be almost equal to the population variance, or it will basically shrink and become almost 0. So, I explained why it will become 0, just hang on, I will give you this example. And then in the method of likelihood estimation, we found out, we took up samples of size n, and we found out, and the parameters was obviously not known. Then the realized value, depending on which sample observation we are taking, the PDF or the PMF for those particular realized values, the probabilities were known, only the parameters are not known, then we want to do it to basically find out the chances that for those parameter replace value coming from the estimate from the sample, we will get the maximum value of that combined probability, and they being IID, we basically multiplied the overall PDFs. That means, for x 1 what was the PDF, for x 2 what was the PDF, so on and so forth, we multiplied them, and all the unknown values in them were the parameters, because now the realized values are known, because once you see, for example, once you before you roll the die, the x value, what is the face of the die coming is unknown, but once the experiment is done, we know that what is the value in front of us. Hence, we know that what is x 1, what is x 2, what is x 3. Similarly, for tossing a coin, doing any experiment, whatever it is. So, given the realized values were known, we basically found out the parameters by differentiating the likelihood function, but we converted it into log likelihood function, because I mentioned that log is a monotone increasing function. Partially differentiated, put it to 0, and when we partially differentiate with respect to each and every parameters which from the population which are not known, and once we put it to 0, if the closed form solution comes, we find out the exact formula for the estimates of those parameters, considering the characteristics of the information has been obtained from the sample. If not, we will use some iterative methods like, say, very simply Newton-Raphson method, Runge-Kutta method, whatever they are, to find out this estimate. Now, when the estimates were found, again we double checked the unbiasedness and consistency for this MLE method, which is maximum likelihood method, and basically agreed upon technically what was basically the best estimate for the population parameter. Now, later on, so considering that, we found out the point estimates for those population parameters. Say, for example, for the exponential distribution giving a as 0, then the sample mean is the best estimate for theta or lambda, whatever we say. In case of a Poisson distribution, the sample mean is the best estimate for theta or lambda, whatever is the parameter we want to find out. Similarly, for when you are basically tossing a coin, I am not talking about the best estimates per se. So, basically we will try to prove that later on if required, but generally this course is not of proofs, basically of utilization and the concepts. So, there are proofs that how you can find out the minimum of a distribution. That means, when you have A and B, between which you are drawing the uniform discrete distribution or uniform continuous distribution, the A and V values, which are the parameters which are not known, how you want to find out and how you want to check the unbiasedness and consistency. So, there are proofs for that. So, how would you find out A using A some A hat, how would you find out B using some B hat, and all these proofs would basically come under the maximum likelihood estimation problem on the general method of moments, and that will basically be the helpful background how you find out the different type of estimates and understand the point estimation concept, which is under the statistical inference. Now, the later on part which we studied was basically about the inference part. The inference part was more interesting in the sense that we want to give some range and a lower control limit and upper control limit, such that the actual mean value or basically standard deviation of the variance for the population would be within that range with certain probability. When I say a certain probability, if it is basically 95%, 99%, 97%, 90%, whatever it is, we say it as the level of confidence, means how confident we are. So, 97% confidence level would basically mean that if we keep doing the experiment, then 97 number of times out of the 100, the range would basically contain the mean value. And then we also later on said that if we want to find out this upper control limit or the lower control limit, we have to pick up a sample of observations n in number and basically find out two different functions T1 and T2, that is small t1 and small t2, which would basically be the lower control and the upper control, and such that the difference of this lengths or technically the between those bounds of T1 and T2 basically will have that parameter for the population with a certain level of confidence, whatever it is. Now, in the later on problems, I did mention that when you are trying to basically find out the interval estimation, and this will become true for the hypothesis testing also, that when you are trying to find out the interval estimation problems, remember always, and I will be repeating it time and again, that for the mean of the and this we are only dealing with the normal distribution per se, because we would not be going into the other distributions. If other distributions are considered, they will be using central limit theorem, they will be converted into a normal distribution. Now, when we are discussing about the mean, provided the standard deviation known, we will always use the z distribution. If we want to find out something to do with the mean, that is in the interval estimation case, provided the standard deviation or the variance of the population is not known, we will use the t distribution with the corresponding degrees of freedom that I have repeated. I will again repeat it as we do more problems. Then we go to the second moment. Second moment, by the word per se, I am using something to do with the variance of the standard deviation for the population. So, if you want to find out something to do with the population, we will use the chi-square distribution. Chi-square distribution with the degrees of n or n minus 1 would be applicable, provided we know the mean, do not know the mean for the population. Then, when we want to utilize and compare the chi-square distribution from two population, provided the mean values for both the population are known, we will use the f distribution with m comma n degrees of freedom, m being the sample size for the first population, n being the sample size for the second population. Then, when we use the try to find out some information related to the standard deviation or the variance of two population, and provided the mean values for the first population and the mean value of the second populations are unknown, then we will use the f distribution with m minus 1 and n minus 1 degrees of freedom. This I have been repeating, I am just repeating such that things become much more clearer to you. And we solved a few problems, very simple problems, and showed that how the tables will be used. We utilize the, we have already shown the z distribution table, we showed the t distribution table, we showed the chi-square distribution table. We will come to the f distribution table later on. Now, when we do this hypothesis testing, please have some patience. Now, this same concept of the chi-square, the f distribution for the standard deviation of the variance, the z and the t corresponding the mean value would be utilized in the same way, conceptually the same way when we do the hypothesis testing also. Now, remember one thing, that in case, and this is again I am saying with repetition, for the t distribution, be well aware that as the sample size increases, the t distribution can be replaced by a standard normal deviate, and we can utilize that distribution table in order to solve our problem. Another thing we should remember, that when we are trying to basically utilize the problem and trying to do it for the interval estimation or the hypothesis testing, the problem arises that in the interval estimation our main concentration is on the interval, such that if the level of significance is 1 minus sigma between the lower control limit and the upper control limit, we will consider that 1 minus alpha, my apologies, or if it is 1 minus alpha between the lower control limit and the upper control limit, we will consider that the rest part, that means if I am looking from my side, the lower control limit is here, the upper control limit here, then the area which is covered onto the left of the lower control limit and to the right of the lower control limit, that sum would basically be equal to the alpha, because alpha plus 1 minus alpha will give you the total area under the curve of the distribution, which would be 1. We will see later on that for the hypothesis testing, that it can be broken down, the same phenomena for the interval estimation can be broken down, each can be broken down into 3 parts, and why these 3 parts would be corresponding to the fact that we are interested to find out or prove some statement in the hypothesis testing, where it is either less than type, greater than type, and not equal to type. So, this I wanted to mention you beforehand. So, as we solve the problems or understand the concept, they would become much clearer to you. So, let us basically now come to the realm of hypothesis testing. So, I did talk a long time in the introduction on for the 18th lecture about what we had done in the 16th and 17th. This will become much more important as we proceed and try to solve different problems from the hypothesis testing and the multivariate statistics, ANOVA, MANOVA and regression part. So, to basically build up the environment, build up the atmosphere for the hypothesis testing, which is the third part of statistical inference, first being point estimation, second being interval estimation and third being hypothesis testing. I will discuss few very simple problems and basically build up the story. So, consider this example. A manufacturer of a particular type of electrical motor has come up with a better HP horsepower rating motor. than its existing competitors and wants to market that product into the market in the market. As is the norm for any manufacturing product, a certain warranty life or a guarantee life for any is to be specified by the manufacturer, and the company under our consideration specifies a warranty life or a guarantee life of 1 year. So, new product is being floated, warranty life and guarantee life is 1 year, which means that if the product fails before 1 year, then the company will replace it, and if the product fails after 1 year and if there is no, say for example, EMI, that means equal monthly installment being paid for the services, then obviously the person has to pay from his or her pocket, the customer, in order to basically repair the parts or replace the machine or the motor. Now, this 1 year is with respect to the market. So, you see what the line reads, I will read it. So, it says that as is the norm for any manufacturing product, a certain warranty life is to be specified by the manufacturer, and the company under our consideration specifies a warranty life of 1 year instead of 8 months given for such rating products. Now, you as an engineer are quite skeptical on hearing that the warranty life is 1 year. So, you think that the warranty life should be for the new products also which have been floated in the market, the same type of products are available in the market, it should be in and around 8, that 1 year warranty life is skeptical and you want to disprove it. So, on hearing that the warranty life is 1 year, you are skeptical and want to test the validity of this statement which the manufacturer has claimed. So, what you will do? You want to basically disprove the statement, you will take some set of machines, test their warranty life, and depending on the outcome which you have, you will basically either agree or disagree with the statement which has been made by the manufacturer. So, this is the general story which we will be building up time and again for different examples for the hypothesis testing problems. Let us consider the second example. The food and beverages company which manufactures jellies and jams sells them in bottles of 100 grams, 250 grams and half kg sizes, and you are the marketing general manager of that firm. So, in order to meet the growing market demand for these products, your company has installed a new high productive automatic jelly jam filling machine, but there has been complaints afterwards that on an average the weight of the 100 gram bottles for the jams are never exactly same, as they have been found to be either more or less than 100. So, many people are complaining if they are getting less, that means the distributor he or she is saying that the bottles are either less than 100 grams or more than 100 grams. That means, so which means the people who will get less than 100 grams would complain, and who would basically get more than 100 grams would not be complaining because they are making an extra buy. So, consider that what extra buy. So, in order to answer this complaint and monitor the productivity of the new machine, the company has entrusted you the responsibility to solve the problem, and hence you would like to test whether the weights on an average for the bottles coming out are about 100 grams with some errors, obviously 100 plus minus some errors would be there, or is there a significant difference in the weights of the bottles. So, that means, if there is significant difference in the weights of the bottle, you will definitely agree with the big complaint being raised that the machine which is basically filling up has some problem, and you will try to basically rectify that. And in case if you find out that the weights are actually almost equal to 100 grams plus minus some error which should be within the level of so called tolerances, then you will say that the complaints which are being raised are not factual, and obviously will give the data from your study in order to disprove the statement which has been raised up by the retailer or the distributor. So, let me continue reading it. Hence, you would like to test whether the weights on the average for the bottles coming out are about 100 grams with some errors, or is there a significant difference in the weights of the bottles, which may be a major concern for the company, hence may necessitate the implementation of some corrective action in order to first identify and then rectify the problem. So, obviously, you want to basically pick up some observation, try to verify the fact which has been said. If the fact is true, then obviously take corrective actions in the factory for the new machines or whatever it is happening, and if it is not true, basically you have to basically substantiate and try to disprove the statement which is being made by the retailers and the distributors, but that should be scientific. That is why you want to basically do that hypothesis testing test. Let us consider the third example. The traffic flow at the main market road in the city of Amritsar is highest in each day in the morning from 10 to 12 hours, and you as the Commissioner of Police of Amritsar want to see whether it is really needed to have the road closed to motor cars and commercial vehicles for that part of the day, that means from 10 to 12 hours, in order to avoid any accident or any major problem. And the number of accidents which has been reported is at a rate of 3 per week with a certain distribution. So, if say for example, that problem has been said mentioned by the newspapers, by your staff, or by the organizations, or by the people, or by the citizens, you want to basically check that if the number is 3, where obviously that is very high and definitely no such accidents should happen. So, you will basically try to check that whether the flow of the traffic between 10 to 12 each day is such that it basically corroborates the fact that there are 3 accidents per week. So, if you find out from the information which you have collected that is true, then obviously you will take action in order to make the number of accidents 0, hence close the road, as it has been said in the problem, close the road for a traffic from 10 to 12. If that is not true, basically then you have to basically find out other means and try to find out why these accidents had happened. Maybe it is due to the negligence of the drivers, maybe it is due to the negligence of the passengers, something must have happened, and you should take corrective actions on those accounts and not close the traffic between 10 to 12 as it has been stated by either the police, as I said, or by the citizens, or by the people who are staying in that locality. Let us go to the fourth example. So, the example is like this: in the city of Guwahati, a new internet service provider ISP has just opened its services and is providing high speed internet services and claims the speed of its services are 500 Mbps. So, this bytes per second. So, you want to basically find out that whether the speed is 500 Mbps or not, and that is what is the claim being made by the new service provider. You are the residents of the city and you are interested to get a new internet connection, but would like to verify this fact and then take a decision whether to take the connection from this new ISP or continue with your old internet service provider. So, person is saying, the new person is saying 500 Mbps, you will basically take some informations or the speed from your friends or people who are utilizing that, check the statement which is being made, and if you are satisfied, you will basically switch over from the old to the new. If it is not, obviously you will continue with the old. That means, the statement which is being made by the new service provider that it is 500 Mbps has not been corroborated from the fact of the experiment which you have done. Now, in all these 4 examples, the main crux of the problem is that you have an issue, some information is provided with some quantitative values, and you want to basically prove or disprove it. Now, what you want to do is that you want to take a separate set of observations for each of the experiment, conduct some statistical test, and then prove or disprove from the based on the fact that some statement has been earlier provided to you. Now, remember one thing, when you are trying to prove and disprove, it is not that you are trying to basically find out what is the ultimate truth. The fact is that you are trying to basically find out that whether the experiment which you have done basically corroborates the statement, either agrees or disagrees. It may be possible the actual statement which has been made by that person is not true, but you do not know. You are assuming that to be true or assuming that to be not true. So, when you basically agree with that statement which is actually not truth, which you do not know, then in that case you are agreeing to the non-truth statement which you are passing a judgment based on the experiment which you have done. On the other hand, if it is true and if you are agreeing with that, you are unknowingly agreeing to the actual truth statement. So, that is 2 parts, that means it is wrong and you are agreeing with the wrong, it is right and you are agreeing with the right. So, you do not know what is actual truth in reality. The other two cases are the statement is wrong and you are going against it. Technically, that means you are agreeing with actual what it should be, not on the fact that what has been provided to you and you are trying to basically disprove or prove. The fourth statement would be basically a statement has been made and that is actually true. What it may happen is that based on the experiment which you have done, you disagree with it. So, in all these four cases, you are trying to basically prove or disprove the statement which has been provided to you. You do not have any information what the actuality, what reality is. And these concepts or what I told you in the last 5 minutes would become very apparent as you basically understand the whole problem from a very simple table format. What is the table format? I am going to come to that later. So, this is the table format. Now, pay attention on the blue part, which is the action and the nature, and especially on the pink part, which is of type 1 and type 2 error. So, consider mother nature, which you do not know, which is an information which is being provided from outside, and consider the fact that there are two statements. One is the null hypothesis, which is H naught, which you want to disprove. This null hypothesis is stated by the person who gives you the information and you want to basically disprove that. Another one, obviously your part would be the alternative hypothesis which you are trying to give, such that using that alternate hypothesis you will basically disprove the person who has made the null hypothesis. Now, in this case there can be 4 different combinations and I will basically state those combinations first and then come back to the statement which I made that they can be the fact can be that actually what the information being given by the other person is untrue and you agree with that untruth statement. Second one mean the actual statement which is being provided by the other person is true and you agree with the truth statement. The third information is that the information being provided by the other person is untrue and you disagree with that, and the fourth one is that the information being provided by the other person is true as per the information with mother nature and you disagree with that. So, these are the 4 information. So, that means actual in reality by God by nature, that is true, and the person says he or she does not know, obviously the person says it is true and you either agree or disagree with it. So, there are 2 informations. Other one is that the actual mother nature whatever it is there, the person disagrees with it. Again there are 2 phenomena, that means you agree or disagree with this. So, that means in all these 4 combinations which are there will basically come out from the table. So, consider the H naught statement is true and you basically reject the H A, which is the alternative one. So, obviously you agree with H naught. So, there is no problem. So, this is the blank which is here. I would not mark anything, this is the one which is here, this is the red one. The other statement is that H naught is true and you reject H A, H A is true and you reject H naught, which means that you are in this cell. So, this cell are the fact, truth or not truth, you are agreeing with that statement which is made. So, that means there are no errors there. But the other 2 part is that if H naught is true and H naught is rejected, then you have a type 1 error which is given by alpha. This alpha would have some information with the 1 minus alpha of the level of confidence, remember that. And the other part is that when you have H naught H A as true and you reject basically H A, that means you are accepting H naught, there is the type 2 error which is known as beta. So, what we are more concerned is about alpha and beta error, and we will try to utilize see that how from the problem perspective these can be done in a very simple statistical format, such that given the information you will agree or disagree with the statement and then basically either support H naught or not support H naught, such that you will try to solve the problems accordingly. So, with this I will end this 18th lecture and continue discussion in the 19th and 20th more of with respect to the hypothesis testing and so on and so forth. Have a nice day and thank you very much.